Hello everyone and welcome to another video. Today I'm going to talk about a big project that I did some years ago. This is the first commercial aquaponics system, first and only commercial aquaponics system that I helped design, build and operate. It is Sweden's first CSA community supported agriculture. It was both the first Swedish commercial system that we know of, the first Swedish vertical aquaponics system, and the first indoor aquaponics system as well. And this was started in 2015 and it operated roughly until 2019. And yeah, I'm gonna tell you a little bit of a story here. It's a fairly big, there's a lot of information I'm gonna share with you. So I'm gonna have to look at some notes later on as well. I'm apologizing in advance if I forget anything, but I'm gonna try to give as much detail as I can. So, first of all, in 2015, there was this NGO called Hemmaodlat, and they had an office in Malmo, and they wanted to do something big. This time, they wanted to build a proper aquaponics system, a big aquaponics system that they can actually produce enough to sell to customers. And this was the vision, that what you see in the screen right now. This was commissioned from an artist in 2014. The vision was that in the office, as you passed by, you could see towers growing plants that you could buy and eat. So this is the vision. This is what we were aiming for. And of course, this was only possible because of a lot of help, namely Sten K Johnsons. They were private financiers that helped put money, and they believed in the vision that we had. Of course, the city of Malmo, they also supported us a lot, and the NGO itself, in which me, Niklas Hjelm, and Andreas Sorensen specifically helped start the design, and then a lot of other volunteers came and helped operate it as well. So yeah, these were the three main parties that got this going, really, I could say. Of course, the actual customers as well would play a good role, a big role later on. So I'm gonna, like I said, give you a lot of specific information. This is one of the first AutoCAD drawings I did back in 2015. You can basically see I was mapping out the windows, all the sizes, all the measurements we needed to do, and how we were envisioning that the system would be. So you have here the towers with the grow lights going all around the windows. Then you have a sump, a radial flow filter or RFF, and the fish tank, and some other components. And here you can also see some small calculations I was doing. We revised these over and over just to be on the safe side. For example, in the early calculations, we were considering goldfish, then we ended up choosing tilapia. The number of zipgrow towers, that was kind of always set in stone, but then we were always, communicating with each other, and also sometimes with another company, Bright Agrotech, which supplied the zipgrow towers. If our calculations were accurate, if they were conservative or not, can we really make this happen? But this was the first design I made, and here you can kind of see the things we were thinking about when starting a commercial system. We were trying to come up with all the material list you have here on the left, all the lighting that's required, the actual zipgrow towers, what we need for the towers. Of course, you need to supply the water to the towers and to collect the water as it comes out of the towers. And how do you hang the towers as well? How are they supported in the bottom? And of course, they have the whole aquaculture and plumbing overall system. And then I also did a little number check. Again, this is what I was talking about. We were trying to run through the calculations over and over to make sure we had the right idea. Were we kind of getting ahead of ourselves? Maybe it's not really possible, but everything seemed to indicate that it was possible. So I'm spending some time here, so if you want to look at it, you can pause the video and actually read what's in it. But I'm not going to read all of it that's here. But yeah, basically here we're trying to calculate, the fish feed per day that we need, how many fish we can support, how much growth from those fish, from the fish waste that is produced, can we support in terms of plants. We're looking at, specific surface area, volumes, flow rates, etc. This is another design I did. This is more about the aquaculture concept, let's say. So you have here the sump tank, the lowest part of the system. Then you have the RFF, where we collect most of the solids that are produced by the fish. And you have the fish tank as well here. I'll be talking more in details about why we chose these things and these designs and so forth. But this is just to give you an idea of how the sketches are evolving through time. Of course, I am not a professional designer, so eventually we had to ask the help of Andreas. He is actually very good at designing these things, and he used several software. I think he ended up using SolidWorks most of all, but he took the first idea, rough idea I had, and actually made it proper. So you see here kind of the view as if you're standing in front of the towers. So you see the towers here with the these little balls here are supposed to represent the plants. You have the light here. So always there is light facing the towers, and the back of the towers are standing next to each other. So there's no wasting light. The support beam for the towers and the light system, and the gutter that takes the water. Here you have the top view on the bottom left. So before it was like we were watching this way, and the main volume of the water is on the right side, which you can see here on the bottom right, a bit tilted. But basically, here in the top view, this is the sump tank, this is the RFF, and this is the fish tank with the fish feeder. So then we had to get specific, actually design these things. Some of the things, of course, for example, the fish tank and the sump tank, we ordered them, but we knew kind of the measurements, so we can already see if they could fit or not, what other things we need to do to them. For example, in the case of the fish tank and the sump, I think we had to build supports to raise the level, or just to not sit in the office floor directly. Remember, this aquaponics system, this commercial aquaponics system, is being built inside an office space that is not made for moisture, water, plants, that kind of environment. So we had to do a lot of retrofitting. But here you can kind of see the overall design. And as you can see as well, both the sump tank and the fish tank have a funnel in the bottom, which makes it easier to collect solids that might accumulate. Oh, sorry. Just to say also that we designed two different types of covers of the fish tank. One is more see-through, so we can observe the fish without having to open the lid directly. We can see if there's movement, if they're okay. The other one is more opaque, so that they have a place to hide away from the light in case they feel threatened. Regarding the RFF, this was the design we were being based on. This is one of the designs we found online from Earthen Group. The basic concept is the water comes in with the solids. There's room and time for the solids to settle in the bottom where they can be removed. And then the cleaner water can go through an outlet to, in our case, the sump tank. So this is actually the design that Andreas did. And yeah, you can see also we built a little support here to raise the bottom part so we can actually empty the solids more easily. Of course, in practice, this was a bit too close to the floor to be comfortable removing a lot of solids most of the time, but it still worked fine. Here you have another design with some more specifics, of the details and such. Again, this is really to show you the details that we went through to make sure this was going to be possible to the centimeter, basically. And here you can see the zipgrow towers. Of course, we ordered them. We didn't design them. They came from the company Bright Agrotech. So we basically had to think more about how are they going to fit in our system? How are we going to hang them? What kind of space for the plant growth are we looking at here? I think we're giving this amount here. And we designed our own light fixture for it. So we basically took fluorescent light, these big tubes of fluorescent light, and we used half pipe of plastic that we also used for the gutter to channel the light specifically for the plants. Otherwise, we would get the light onto our eyes all the time outside, and that would just be a waste of electricity. This way, the light is focused for the plants that are right in front of it. And the light as well had a controller. This is because we're having electricity very close to the water, so we need to make sure there's a lot of safety involved if there is some sort of leak happening. And we built also a wood support with a little hook here. You can see also here that we would then easily take on or off if we needed to in a wooden beam that we would later build. And here you can see more details about that support. Additionally, we were also looking at specific connections for the gutter system. This one is a plastic connection that has also an outlet to the bottom. I don't think we ended up using this one, but I added it just in case you guys were curious about the sort of things we were looking at. This one we did use, so the gutter run along the main, what do you call it? The main window area, right? That's like 20 meters or something. Maybe not that much. But anyway, at some point it reaches the corner and then it turns 90 degrees that goes to the sump tank. So we needed this little 90-degree connection to fit both sides of the gutter and to make sure that everything flows without issue. And these are specifically made. I mean, you can buy these online, so, but we still wanted to, get the designs, ask the designs, make sure that we actually can fit this, that it fits the gutter we have, and that everything is smoothly before we buy and before we install it. I did one more design just to get an idea of things in 3D. This was using Google SketchUp, basically just to have a vague idea of how things were going to stay. Do we really have space considering the distances we were thinking about? It all seemed to work out, but of course this was a very ugly model because I'm not really that good in 3D design, especially at the time. So Andreas actually built something much better that we could use as a reference. So that's what I will be mostly sharing. So this is again a top view, what I shared before. The entrance to our office is in this area. There's a bit more to the left and a bit more behind, but this is the main area that we will operate in. So here are the windows, and you have the towers, the whole system is here, and there's a little bit of a window pane, maybe that's the name, and below that are heaters. But we always built it in a way that there's no risk really of a lot of leaks affecting anything. There's nothing really important behind, and we didn't have to raise the gutter that much to take care of that. So everything was really properly made, I have to say. And you get the idea here of how it looks. There's a lot of design, so bear with me. Here you can really see the detail. Here you can see the connection of the fish tank, how we collect the solids at the bottom. It's a bit more complicated, I will explain it later. But it gets bottom, then it goes through the bottom up into the RFF. That's where it has time to settle, and we collect it on this valve, but the cleaner water then goes into the sump here. And this is the view where you just see the line of towers, and then eventually you have that 90 degree I mentioned about, and then the gutter goes into the sump tank. And you can see already that there's kind of two flows of water. So we were actually operating this with two pumps. One pump would recirculate the water in the sump between the aquaculture component. So the water arriving to the sump, either from the towers or from the RFF, gets put back into the fish tank. In theory, this is the cleanest water of the system, so it makes sense to send it back to the fish. But also, there's another pump that sends the water to the towers, and then that water also gets cleaned through the plants and then returns to the sump. Here you have a bit more of a view of how it feels in 3D with the plants. You can see here the support. It's basically just a long wooden tube, but we would be able to very simply move the lights on or off, or the towers that come already with some hooks. Here you also see the 90 degree. You see the sump. You see the supports I mentioned that we had to build, the fish feeder. I believe this is a flow meter. Later you will be able to see how in each tower we had a little valve to control exactly how much water is coming. Here's another perspective on this. And fun fact, this room right here is an ATM room. So So sometimes people would have to come in that service the ATM and get in money or take out money, and they would pass by our growing area. And every time someone used the ATM, we hear the beep, beep, beep going on. But yeah, still we're in the designing phase. Here you see a bit more nicer design. Again, this is all by Andreas, with the input of Niklas and me. But mostly them two were doing the heavy lifting after we did the initial calculations together. Here you see there's a little bit of this is an earlier sketch. You can see the gutter is quite raised. In reality, this was much closer to this bench kind of area next to the window, so it's not that raised. We lowered it a bit, also to make it easier for us to inspect the plants and the towers and all of that. And here you can also see that the gutter after the 90 degree is going over the sump. And if I remember correctly, what we ended up doing was to drill a hole in the sump itself, so we wouldn't have to raise this so much. You can see that hole I'm talking about now. So we decided that this was easier. Because we didn't need to have that much water in the sump anyway to fill to the top, so we could afford to have that hole. And there were always constant levels. Again, these are still some more designs up here, so you really get an idea of how we were thinking of things. Some of these are not really in order, but yeah, you get basically a rough idea of how meticulous we were about this. Another view of the aquaculture component without the connections yet. Some more close-ups. You can see here the gutter. And in practice, the towers fit very nicely in that gutter. Here still with a raised system. Be a little bit of a close-up on the sump and the RFF. Some more info here on the tower systems. So yeah, I've already touched on all of this. Basically, you can see a bit more in detail the parabolic shape around the light to focus the light. Oh, wrong button. Okay, let me just fix this. There we go. So then we actually ordered the things and things started arriving. So here you can see these two tanks. Both are a cubic meter, so pretty big, pretty hard to fit into the office door. I believe they were made of fiberglass, but I can't be 100% sure. They came from China though. And yeah, they're already kind of in the area where we were going to put them. These are the zipgrow towers that came from America. I believe we ordered 24. 20 we used for the Aquaponics CSA, and the other 4 we kept around for testing other things or other experiments. Here you can see the building of the wooden support where the lights would stay, and with the little controller. Eventually we would move that controller up, and this is part of the gutter plastic that we used to focus. We experimented having also aluminium foil, but in the end it was just enough to have it with the white that it came on. And here we were testing that light system with the previous homemade zipgrow tower, you could say, that we had from other experiments, just to see how the light was being channeled properly, how the flow was working through, all of these things. Here then we also, once we got the actual towers, we tested the light system and the towers in the specific area where they were supposed to be. So here you have part of a gutter, 1 tower, 1 lighting system with the controller already here in the top part, and this we can connect to timers and things like that. And you can also see here from another perspective, you can also see the areas around us, outside of us, with a little falafel place, residential building, a little small park. And here you can see we tested one of the towers by adding already one semi-grown plant, just to see how the flow was moving, even though they had a plant in with the roots and all of that. All seemed to indicate it was growing well. Here you can also see we already built both the wooden support for the towers and the light system, as well as the piping in black here for all of the towers. And so it's a main pipe tube, and from there you have little strips of pipe with a little valve that goes into each tower. So it's very easy to adjust it a little bit. It's very flexible in that sense. We will later on have a little bit of an issue with those little pipes, but in the beginning at least it was all working fine. Here is a bit of a close-up of that. So the pipe itself is fixed into the wall, and then you have the connectors for different segments of the pipe. So this is also made in case we get a blockage. We can stop the flow, take a piece of the pipe and inspect if that's where it got clogged. Same goes for the little ones. And of course the support we have here, and as well as some of the electricity connections we had to build for all of these lights. Here we're cleaning all of the surface to actually get ready to mount everything together. You can see in the distance here already we have the sump in place. And like I said, we were putting these in front of the windows, but it was not, first of all, it's Sweden, so there's not a lot of light, especially if you're doing indoors. And we wanted to be able to grow all year round. And yeah, we need artificial light. So even though the vision is, of course, that people see the plants and people were able to see the plants, we would never be able to rely just on natural light in these conditions. And these are all standing on this window pane of sorts I'm talking about, and that's where there are heaters below, but we didn't really need them anyway because the lights already are creating so much heat. Very out of focus picture, I'm sorry, but here you can see how snugly the towers were fitting in the gutter that we built. And here you have already the fish tank in place with the two different types of lids. Still no fish feeder. The connections I think are already in place for the RFF, which will eventually have a lid. And then from the RFF goes into the sump. And here the water from the towers is coming here. So here we're doing basically the hydraulic testing of all of this, making sure the flows are going well, that there's no leaks anywhere. You can see here there's still no flow to the fish tank section, so it's still partially done. Here's another angle. So I think maybe it's actually still not connected to the RFF, but basically we're putting everything together and see, okay, we've designed it, we know it should work in theory. In practice, does it all fit together? And it did. And here on the right side, you can see we're trying to put seedlings on the towers to experiment with that. So the zipgrow towers, it's basically a block of plastic. Inside there's this matrix media out of non-woven plastic, I believe. And you would put the plants in there. You are advised to use this wicking material that you put in between the slices of the matrix media. That helps hold the plant together. And if there is something wrong with the flow, at least that material will make sure the plant doesn't dry out. So each tower has two of these halves that fold up. And you use a little hook to get them out of the tower. That's why the tower has that black strip. Well, it's not really black. It's the media is black inside, but there's like a gap in the middle. So it's supposed to they use it like a zip, hence the name zipgrow. But yeah, we were experimenting, basically ensuring that everything was running fine with our plants, with our style of growing. And once everything is kind of assembled, it's not completely done yet, but this is kind of the panoramic view of all of it. I'm taking this from the perspective of a board where we used to have meetings. And you can see basically the support is here for the towers. The flow is already in place going to the sump. The lights are not mounted yet, and there is no flow to the fish tank here. It's still not done, but it's just a matter of unplugging and putting it. So it's basically done, and then we added those things. And what did we do? What did we do with that? Well, here you can see how it came to be. As you can see, we got pretty close to the vision, if not completely on the spot, on point. So the first picture is the view from the outside. You can see the lights are quite bright. We would have them on a timer, but still on a winter, they really attract attention. But yeah, we have the towers growing and the lights. And then inside, you can also see how things look. So here in inside, you can see Nicholas inspecting a plant for bugs. You can see the towers, you can see the gutter. You can see how the sump has a lot of the water filled. You can see the fish feeder in place, the flow going to the fish tank. You can see the bit of electronics here. You can also see the fish feeder timer and a little monitoring system we have for some parameters. But I will talk about these later. Here you have me with a giant tower of lettuce. So this is the advantage of growing vertically. Of course, you can have a lot of growth in a very small space. And with this massive, it is actually very compact. As you can see, we're only having the growth in a very narrow, it's not more big than it's not even a meter across narrow strip, but then we're growing vertically. Of course, the fish tank and that, all of that is using a lot more space. But once things are growing well, you can get a lot of product, and here is the proof. Here you also see another picture of me. So after designing, after helping building it, part of the operation, not only the seeding, the transplanting, the harvesting, checking for bugs, etc. Part of the maintenance that I would do is do regular water tests, because an aquaponics system has a lot of nutrients that allows the growth of a lot of plants, but to be completely perfect, sometimes you need to supplement some things. And if it's not completely perfectly dimensioned, meaning the type of fish, the amount of fish, the type of plants, the amount of plants, the flow, the filtering of the solids, all of that, if it's not completely in sync, eventually over time you get deficiencies. So here I am collecting a sample from the sump, and then I would go downstairs to a basement where I would do some chemical tests to check ammonia, nitrate, nitrite. Those are the key parameters for the aquaponics system. But then I would also analyze other things like iron, potassium, phosphorus, macronutrients, micronutrients, things that might indicate we need to add something extra. And I will talk about that also later. Here you can also get a glimpse of the cabling system. Our cable management was not the best, especially in the beginning, because we were still experimenting with things. Basically, you see some timers here. Here you have an air pump, and I believe both the water pumps are in the sump, and eventually we would move them out of the sump because they would get clogged more easily in the sump, the type of submerged pumps we were using. Whereas when we used pumps that were outside of the sump, that was much easier to operate, and we had safety things in place so that we would never really have leaks. And I have to say, over 4 years of operation, we never really have a disastrous leak. Of course, sometimes we had a small leak, a few 100 liters, for example. Considering this is a 2,500 liter system, that's still pretty good. So it was never really bad. But of course, being in an office space has its risks. Okay, and here is a view from the outside. You can see, especially in colder months, how there's a lot of condensation in the windows, and eventually we discover, we can have problems with mold. We didn't really have mold, but we could have problems with that, so we started operating some fans inside to keep things cool. And pests was also a big issue, but we were pretty on top of it most of the time. Here is some of the examples of the things we would grow, and on the left here you have sage, then you have thyme, and then you have big leaf basil with my hand for comparison. And the whole point of this is that it is a commercial operation. So being a community supported agriculture project, that means that people actually would pay us once a week for this little bag of fresh herbs that we would grow. And let me check my notes real quick, but I believe they had, every week they would receive one full head of lettuce, one full chard, one full bundle of basil or other herbs, and then one extra plant. And I believe the price, well, I'm not sure about the price. I might have been close to 200 kroner. I'm not sure. Obviously, we were a bit more extra than what someone would say would be a comparable supermarket thing. But in fact, because we were giving them more plants and they were bigger and they were more sustainable, we would say we were actually cheaper. But still, the system was designed to operate between 8 to 10 at the max, but we always kept it much less, about 4 or 5, because we wanted to have that extra buffer in case something happened, because it was the first time we were operating a really big aquaponics system. I mean, I've done my thesis systems. They were big, but they were not 2 cubic meters big. They were only a few hundred liters. So we never really wanted to push the system to the max, because it wasn't really about the money. It was more about proving that it can be done and learning ourselves how to handle all these ebb and flows of the trade. So yeah, that was basically the commercial aquaponics systems that we built. Now I have more content for you. So first of all, here you have some information. This is in Swedish, but basically this is what I was telling you about. Maximum we could get up to 8 to 10 people. Here you have some periods. We will do these in certain periods because sometimes we want to have a break in between the growing so we can disinfect the towers, clean everything properly, especially because most of the times we would end up having pests. So we need to disinfect things at some point. And here you see, I don't know if these prices were final or not, so take it as you will. But there are some calculations here about what people get, how much we can actually grow, what are kind of the costs that we're dealing with, what kind of towers we want to build. So we would decide, okay, 4 towers can be for basil, 2 for coriander, 2 for parsley, mint, chard, kale, pak choi, tatsoi, things like that, rocket salad, rosemary. And yeah, I'm leaving this here so you can take a look. These are just basically the specifics that we were discussing about. And you can also see here one of the early sketch of the systems. And we're discussing also flow rates and things like that. But basically, this is what we were operating with. And then we have some of the videos that I made. So you can also see here, this is during the construction, basically. So you have the fish tank, the sump, and you see the towers already with the light fixtures in place, and how everything is starting to look together. So still pretty empty. Then here you have the towers already with some of the plants, very early seedlings. And we would usually mark the towers with what they are, the type of lettuce and the date when we added the tower. So 6th of October, for example, there. 7th of October. And then once everything is growing, this is the kind of luscious growth that you expect from this. While outside is snowing. So this was me kind of showing how powerful it is when you can grow indoors, that you're not reliant on the weather outside. Then once from one other Portuguese channel I did a tour in Portuguese, but I'm going to show you the same videos and talk roughly the same in English so you can also see. So this is the view from the outside during a winter day. So yeah, very, and this is the neighborhood kind of around. You see there's a lot of snow, typical winter day. And actually, we would start our journey, so to speak, with a vermicomposting station. So these, IKEA containers is where we have worms. And we would add food waste and some cardboard and coffee leftovers and things like that. And the worms is Eisenia fetida, the red worms, they would produce that to soil. And that type of soil we would use to seed and to get the plants up to a seedling stage. Here you see one of the worms. I will show you more. But yeah, there's these you can stack on top of each other, and the bottom one basically is slightly elevated so that the liquid, the leachate that is draining through, can be collected and not be permanently soaking the soil. So we want to also use that liquid to water plants outside, try some experiments of our own, and yeah, it was we were pretty happy with this. We were kind of closing the loop, so to speak. Here you can see the worms a bit more in detail. So we had a lot of worms, and yeah, they did a lot of work for us. We would also add them to the towers because the towers are made for aquaponics, not just hydroponics. And that matrix media, that mesh of plastic, the worms can easily go through them and get their food and find their food from the solids of the fish that would also get stuck there sometimes, or from the plant roots or decaying organic matter. After we got the soil, we put them in our seeding station. This is an ebb and flow table tray. There's a little sump here with an air pump and air stone, and it would flood 3 times per day. This is all a hydroponic solution. It would flood 3 times per day. Even though we are growing with the soil in some cases, we're also growing without soil, so we need to add a little bit of hydroponic solution. And this is basically where we have the seedings. This is where the water is draining and coming from. And yeah, we wait basically until the seedlings are in a nice big condition. So usually in the supermarket you get plants around this size actually, but this is the size we would put them in the towers because then they would grow even more. And yeah, here I'm mentioning that this coriander or parsley was ready, but this lettuce still could use a little bit more time. And of course sometimes we also had pest issues here, so we had to use these yellow stickers to attract them and to prevent that, and inspect them very often as well. Then the aquaculture component. Here you see the fish feed, and this still very kind of makeshift with the duct tape and all, but it worked. It would dispense the feed 2 times per day. I think we calculated something like 200 grams because we had 20 tilapias or something like that. Yeah, 30 tilapias, sorry. 30 tilapias, 2 times per day feeding. You'll notice there's a bit of dark water. That's because sometimes we would add humic acid. And yeah, and this is the part that I haven't talked yet. We have a solids lift overflow here in the system. So there's a pipe within a pipe. The first pipe prevents the fish from entering that kind of area, but it has gaps so that fish waste can be sucked in. And then it goes all the way to the top where it exits the system through the main standpipe that also determines the water level. And from then it goes to the RFF, which I will also show you soon. Yeah, you see the standpipe. And we also had some air stones in there for keeping the water with enough oxygen for the fish. So yeah, the water goes down here. We have valves in case we need to maintain things, so this was pretty useful. And here in the RFF we have drilled a hole so we can also inspect the water and see the water flow as well. And yeah, and then the solids would settle here, and we would, or mostly I would, come here with a bucket and try to empty it. But you can see a bucket doesn't really fit easily because it's very close to the ground. But it was enough that we could do it. And finally then the water goes to the sump. And in the sump we had several things going on. First of all, we have also aeration. Sometimes we would pre-wet the media from the towers to get nitrifying bacteria in them, because again, remember, that's our main biofilter system, is the towers. These towers is where all the nitrifying bacteria are. And here you see also the monitoring system I was mentioning. You can see the EC, which is not really useful in aquaponics. the temperature and the pH, and this is the fish feeder that tells the time when it's going to feed. You can see some of the plumbing, and eventually we would also have like a DWC raft on the sump. Here you can see the pump has already been moved, and we have also an extra area here. We were always experiment basically because we were trying to optimize how can we make it easier for us to operate it on a day-to-day basis. But yeah, it was much better when we had the pump outside of the sump, I think, because if something is wrong, you don't have to get your hands that dirty. And then here is the tower system. So here I will show you in the next video a bit more how that looked. Before that, you can see I have just a short video here showing you when the fish are feeding, because the water usually was dark, so we actually didn't see the fish that much. Yeah, here you can see the water moving because the fish feed has just been dispensed, so the fish are feeding themselves. And we would actually try, not me because I'm vegetarian, but they would try. One time when we reset the system, we grilled the tilapia, and I think they agreed it was not the tastiest fish, but you can eat it. So yeah, here you see the fish feeding. You don't really see the fish, but you see them feeding. So here you have a close-up on the tower. Here you see the little valve I was mentioning. That would clog up fairly often, but it was also easy to take out, pass through, rinse through water, and then put it back in. But that is one issue when you're operating a system with fish solids and you don't have a very, very good solid filtration beforehand. So you can see by the way we design things that a lot of the solids actually can pass through the RFF because it's not the best effective filter for solids, and then they would come to the towers, but in between they could get clogged in those little pipes. So that was kind of a failure point. Here you see the gutter system, the lights. You can see how the light is being focused for the plants. Here you see much better the gutter and the water coming down from the tower and how it extends all the way through those, 15 meters, something like that. And here I have to rely a bit on my notes to remember everything. So each tower has their own regulator valve. We have the fluorescent light with the control and the timer. We have 20 towers with lettuce. We would try usually different types of lettuce, so that's something our customers appreciated, to discover the different types of lettuce. Here you have a little close-up of the controller, how the light is being focused. Yeah, it's all very adjustable, so we could always move them apart or closer together if we need to. That was something that was very well built. That's why we built it this way, because we have a lot of flexibility as the plant is growing. And yeah, this is one type of lettuce. We have the name, so like you can see Batavia Relay, Cost Little Jam, Red Bowl something. Yeah, you can see here, Batavia Relay, Cost Little Jam, Red Salad Bowl, American Brown. So these were the main 4 types we were doing. Then we have Chard, I think. Chard. These were the easiest to grow, basically. These were extremely, extremely easy to grow. And the kale was the one we really struggled with for some reason. We never really figured out. We think it had to do with nutrients, but we supplied the nutrients anyway. We were always on top. We were doing regular weekly or bi-weekly chemical tests to determine what we're missing. We would both observe the leaf discoloration and we do the testing with our little lab, and that helps us determine basically what is going on. But for some reason the kale we always had trouble with. You could see only one of the plants really grew to a decent size. The seedlings never really took root. And looking back now, I think maybe this could be some issue with companion planting, because some plants don't really grow well with each other, and we were not really thinking in that specific term back then. We thought, okay, these types of plants are mostly similar, easy to grow, so they should go together. Here you see some more shards. And basil was also very easy to grow. And yeah, we would usually grow the big leaf basil and or genovese, and the leaves are very big. You can see the very thick stems as well, and you can see the size of the leaf here. But I was mentioning in the video here that we've had leaves the size of my hand, so it can grow really big. And sometimes here you can see there's sometimes less growth. What I'm explaining in the video is that sometimes we have issues with the water flow, but also we start observing like a rotting of the stem of the basil. And we never really realized why that was happening. And something also that tended to happen later on was that sometimes the way the plants grew in the tower would make it so that the flow would start dripping from the leaves into the floor, and we would lose water that way. We were never really able to fully fix the problem. We tried asking for help for Bright Agrotech. They gave us some tips, but it never really fixed the issue. We tried tilting the towers a little bit. Here you see parsley and coriander. But yeah, it was hard to fix that. So that's one of the things that with these towers that was not really working well. It could be because some blockages from the fish solids. Maybe we weren't maintaining the matrix media so well, or maybe some fundamental design with the towers. We never really understood that. Here's some more basil. And just checking my notes, see all the plants. Okay, so we have parsley, coriander, and we grow mint, thyme, sage, rocket salad or arugula, and chives. And yeah, here you can see a little bit of discoloration from the basil. But we were always pretty on top of it. As soon as we noticed something like this, we would compensate. I will talk in the next video about the kinds of nutrients that we added. Fairly simple stuff, common in aquaponics. Here you see the mint, and something that we also started doing later, some of the plants that are easier to propagate and clone, like mint and basil, we would add them along the gutter to start developing some of the root system. Not really for the towers it's themselves, but mostly because sometimes we need the plants for other experiments, so we would just do it that way. Here you have sage and thyme, and this is more... this is the rucola. Okay, the arugula and then the chives here. But yeah, throughout the operation of all this, we saw all sorts of pests, aphids, thrips, spider mites. Once they get into an office indoor building, and I have a video about pest management that mentions this, with videos that I took of the bugs of this system and photos. Once they get here, there's no predators. So sometimes we would do biological pest management. We would buy specific predator bugs and release them here. But that's kind of costly, and eventually they starve out because they eat their food source, so it's not really sustainable. We would also do our own biological sprays to spray on, or sometimes we would just reset towers and disinfect things. Sometimes if we see that a tower is very infected, we would just isolate it, quarantine it, put a new tower, and and try to salvage the other one. So yeah, that was basically the system. Operated throughout 4 years, and eventually we it ended because Hemmaodlat moved to another location, and I think they also have other plans of how to use this. But we proved the concept, basically. We proved that you can design it, that it can work, that you can sell to customers. We sold at least 3 of those 4 years that it was operating on a pretty continuous basis. And the fish part, because it's such a small system, the fish part is always the most trouble part to make profit from aquaponics. It's really the plants that are the cash flow, so to speak. The fish is more like the sustainable way to grow it, other than using the hydroponic systems that you need the minerals that have to be mined and all of that. And yeah, often we will have to replace. Yeah, we will lose water through evaporation as well. So we have to replace a few hundred liters every week. But overall, worked pretty well. And the new members that would come, they would help a little bit with the system. And just going back here, so we have something to talk about. Okay, still there is a video, sorry. All right, and then the members would come and they help, and then they can do their own experiments. So lastly, in terms of nutrients, this is the assortment of things that we used. So early on, when you're dealing with starting the aquaponics system, building a nitrifying colony, if the pH is too high, we would add phosphoric acid, like this pH down here. And later on, we would find the problem that the pH actually goes too low. Even though we add tap water and replenish it, we would eventually have to start adding lime to raise it up a bit. So that's a fun fact. But yeah, phosphoric acid, that's what we use initially when we're still building the bacterial colony. And this took about a month, I think, so at least a fair amount of weeks. And then when we have the seedling stage, we use the other components here on the right, which are this seaweed extract and this rooted first feed. We didn't really use them that much, just a few times. Especially the seaweed, we would sometimes just add it to the overall system in few amounts because it has some trace nutrients that might not come from the fish feed that we are feeding the fish and their metabolism. So that's a way to add things that maybe are not a problem on their own most of the time, but it's good to have a base level for that. Sometimes some things we did need to add sometimes are the potassium and phosphorus a little bit, but mostly the potassium. And we would add the kelp and this potassium product here, as well as potassium sulfate. This kelp has an NPK of 0.001. This one has 0.050. And then potassium sulfate is the more pure chemical compound. And then the humic acid, that would also help for magnesium. So yeah, these were the things we were using, and certain products are more, for example, the kelp is poorer than this other more concentrated one, but it's also much cheaper, and in theory also much more sustainably sourced, the kelp being a marine product. So yeah, we had to juggle, kind of thinking, okay, how much are we missing? We do the test, we calculate. These bottles also sometimes give you the dilution factor, but by doing the tests with the lab that we had, we can calculate how much we really need to add to reach the target concentration that we think we may be lacking. And yeah, that was basically, these were the products. And the humic acid specifically gave a lot of dark water coloration, which made it difficult for us to inspect the fish. So sometimes we would not be able to spot if a fish had a problem until we found remains of it after it had been eaten by the other fish, or just it started floating around dead. We never really lost that many fish, but we also didn't really produce fish, even though there were males and females. Only a few times we found baby fish that somehow got through the solids lift overflow, passed by the radial flow filter, and then went into the sump. And then we had some sort of, by then we had some deep water culture raft. So it was kind of protected and it was just living its life there. Something that we did need to supplement a bit more was the iron. So this is chelated iron, 10%. This is fairly common to have to supplement in organic systems and specifically aquaponic systems. I also used this product in my thesis aquaponic system and my anthroponic system. And yeah, fairly limiting nutrient, I would say, micronutrient. Still, we didn't need to add that much for it to have an effect, and it would last a long time in the system. And lastly, we had Epsom salt. This is more for the magnesium, and also helps keep the fish healthy in some sense. I forgot how specifically it does that, but these were basically all the nutrients that we're using. So not a very big variety. Most of them are just, for example, the potassium is 3 different types of way to add potassium. So we were using these because we had these big demandings on us. We wanted to have perfect crops for the customer. We had this big amount of plants, and the fish that were being fed was just not enough to reach that perfection that we were trying to reach. So that's, of course, one of the things with the aquaponics system, that you don't really get the specific control that you get with mineral hydroponics. But yeah, this was my exhausting retelling of this big project that lasted 4 years in Sweden. Sweden's first commercial urban aquaponics vertical indoor system. That's a mouthful to say. And as you can see now, you've seen how it looked operating. You can see the vision. You can agree with me. I think it was pretty close to what we had set out to do. And again, you have a lot. If you go back, pause if you want details. And I'm not going to be able to reply to all the comments about details because I don't remember them that well. And hopefully I supplied you with things to think about, how we approach the problem, how we design things, what solutions we used, that you can find useful if you're thinking of doing something similar, or just lessons of the experience that I just told you of running it, that you might find useful if you're running a small aquaponics system or if you're planning to do a big aquaponics system. But yeah, thank you for bearing with me through all these minutes. And I hope you enjoyed the video, and I look forward to seeing you in the next one. And yeah, have a good weekend.